This video is going to look at another example using the fundamental theorem, and this example is going to look at a function including the absolute value, and we're trying to calculate the area underneath this particular curve, and we are going to be looking from the interval from 0 to 4. So first we need to graph this function to see what it looks like with the absolute value. So if we go to our calculator, we can type in the absolute value, go over to math number, and number one is absolute value, x squared minus 4x plus 3. And looking at the graph, let's see, we'll zoom in a little bit on this to change the window. X minimum will make about -4. X max, I believe we can make around 6. See what that looks like. And our y value, we can adjust the y minimum, it looks like. And we'll make that a -3. Alright, and that should do for us. If we look at this graph carefully, notice the function never goes below the x-axis. And we're looking at calculating this area. Well, in order to integrate this, we know that we want to go from 0 to 4. So here we go from 0 over to 4. But we notice the graph here is above, so we're in good shape. But how can we integrate this part of it that goes above due to the absolute value? Because we know this is, without the absolute value, we should just have a parabola. And if we go back and look at that, let's see what we get. If we go back and look at our function, and if we delete the absolute value just so that we have x squared minus 4x plus 3, and we look at the graph, notice that part of the graph here that was going above is now curving below. So we get our parabola going down below the x-axis. So if we were to integrate this problem without the absolute value, we know that the part of the graph here, which it looks like this is going from 1 to 3, this part of the graph would normally be curving below the x-axis. So if we're going to set this up to integrate, how do you think we might be able to do this so that we know that when we integrate from 1 to 3, this is going to be giving us a negative value? So this is an example where we know that this is going to go below, so when we integrate, we could set this up as the integral from 0 to 1, and we would have x squared minus 4x plus 3 dx. And we can integrate this piece normally because we know from 0 to 1 this part is already above. But now when we integrate this part from 1 to 3, we have the exact same function, x squared minus 4x plus 3. But now because this is going below, we know that that's going to give us a negative value for area. So out front, we can put a negative sign here so that we'll make this a positive value. And then from 3 to 4, we can look at calculating this area. So now all we have to do is integrate, and because we have a basic polynomial function, that'll be very simple to do. So we would end up with x cubed over 3 minus 4x squared over 2 plus 3x. And keep in mind we need to evaluate this on the interval from 0 to 1 minus, and then we look at the integral here, and you're going to realize that we're going to have the exact same integral. Except for now we need to evaluate the integral from 1 to 3. And the third one is going to be the same as well. So we have x cubed over 3 minus 4x squared over 2 plus 3x. And once again here the interval though is from 3 to 4. So now if we evaluate each one of these, if we plug in the upper limit 1, we're going to end up with 1/3 minus 4 halves plus 3. So this is going to end up with 4/3. And if we plug 0 in, that's all going to cancel out. So that becomes 0. And then we have minus. And the next one, once again, here we plug in the upper limit 3. And everything here is going to cancel out. Minus the lower limit 1. Well, if we plug 1 in, just like we did over here in the first one, 1 was the upper limit in the first integral, and we had 4/3. So if we plug 1 in here, we're also going to end up with 4/3. And once again, for the last interval, we plug in the upper limit 4, and you're going to find out this will reduce to 4/3 minus the lower limit, which is 3. Well, over here we plugged in a 3 and we ended up with 0. So once again, if you plug a 3 in, this is going to become 0. So we have 4/3 minus, and notice this here, when this middle piece, 0 minus 4/3 is a negative 4/3. And now you can see the importance of why we needed to put the negative here, because now the two negatives are going to make this a positive. And then the last one we have plus 4/3. So now we end up with 4/3. Two negatives make it a positive 4/3 plus 4/3, which this should be the case because now we can verify that each one of these, the area we have is positive, and we know that the area that we calculated here in the orange that's going below is going to give us the exact same area if this curve is flipped up due to the absolute value. So then our final answer, if we add all these together, is simply 4. Now the reason I really want to look at this example with the absolute value is because I want you to realize when you have an absolute value function, we know that that's going to make your entire function be positive, but when we integrate, we need to come up with an equation that's going to give us the entire function so we can figure out how to integrate this without the absolute value, and we need to make corrections for any part of the graph that is going below so that we can make sure that we change it to a positive value when we calculate the area. Now you may think, and we certainly could have done this, when we were integrating this part here, we could say, well, we know that this part, when we integrate from 1 to 3, this is going to be a negative 4/3. And to me, probably the easiest way to be consistent is we could just put a negative in front like we did here. One option is we could still keep this positive, but change our limits. Instead of going from 1 to 3, we could integrate from 3 to 1, and by doing that, that would change the negative sign to a positive, because remember, when we switch the limits, that will switch the sign of our answer. So again, just be careful when you're looking at the absolute value and try to identify the function without it and see where you need to make your corrections.